Okay, we were talking about the buffers, and buffers are temporary storage locations inside the devices. Like we have printer buffers, we have keyboard buffers, and these buffers are simply there so that they can compensate the speed differences. Like say CPU is faster and the devices are a bit slower. And definitely CPU has to be faster, processor has to be faster. So the CPU will be able to carry out its task because now the data will be received from the printer buffer. So this is what the buffers are, you can see, are areas of memory that hold data temporarily. They prevent slower processes affecting CPU performance and also allow the CPU to carry out several tasks at the same time. So this is what the buffers are doing. Buffers are helping out so that the CPU can carry on its task faster and it will be free to carry on its operation. Are you clear about this buffers completely?
Yeah.
Now, again, examples of software of interrupts again is discussed here. Software interrupts, division by zero, can't find exit file, two processes trying to access the same memory location. Hardware interrupts, for example, printer jam, or running out of ink, timing signals, input and output hardware processes, and user interaction. So the same thing has been discussed here once again. And then let's see the sample questions and answers. Uh, Human computer interfaces are sometimes referred to as WIMP and post-WIMP. Explain the difference between WIMP and post-WIMP and describe the advantages and disadvantages of the two types of interface, the way we talked about. So if you have understood this, then I think it will not be a problem for you to comprehend at all. And still, okay, now let's have a very clear uh, look at the answers that were the sample high level answers. A WIMP environment, you can see WIMP and post-WIMP. A WIMP environment involves the use of pointing device such as a mouse to navigate a screen and select options from a menu or click on an icon. See, such well constructed answer. With post-WIMP, the user doesn't need a pointing device since this only works with the touch screen. The user simply uses their fingers or stylus to carry out movements, just pinch and rotate, as well as selections. Selections is something that is linked with WIMP because in WIMP also we are performing the selection process by using the mouse again. And here in post-WIMP we are using the pinching and rotating. Now, moving to the second question, advantages and disadvantages of the two types of interface. Due to situations like the 2000 pandemic, touchscreens which are used post-WIMP have obvious disadvantages since they can allow the transfer of viruses and bacteria between people who touch the same screen. However, their big advantage is that no input devices are needed, such as mouse, which could equally transfer viruses and bacteria. Post-WIMP also allows actions such as pinch or rotate, which would almost be impossible using a mouse. And here we can see one advantage of WIMP is, as you can see here, one advantage of, now is it making sense? Is it like something that you can see for yourself that I think we can handle something like that? Isn't it?
Yeah.
Fine. So this is what
Yeah.
the whole thing is about. So this is how you can answer, like see so intelligently. And the examiner is treating this as a high level answer. Okay. Part A
Yeah.
involves explanation. Your answer needs to show the main differences between the two types of the interface. In part A, you are going to give the advantages and disadvantages by giving a comparison. So this is what they expect you to write. Now, there are a few other questions also, like part B, explain the term screensaver included in your answer, the reasons why screensavers are used. And I think you remember the use that why we use the screensavers and why were they invented and what is the advantage of this. So I think that is very clearly indicating each and everything.
Yeah.
Okay, fine. Now moving to, and apart from NCR's name three other functions and carried out by the typical operating system. So this is also what you can see here. Three other functions. And now let's see what is the answer for part C and B. Screensaver is a moving or still image which appears on a user's screen following a period of inactivity. See, this is the same. The definition that you need to be very careful about. Example of OS functions include multitasking, user account management, file management, hardware management, memory management, interrupt handling. So this is your answer to this part. Apart from HCI, name three other functions carried out by the operating system. So you simply need to mention, that's all. That's why you can mention any. Just leaving HCI, you can mention any others. Okay, fine.
Yeah. Yeah.
And I'm not showing the low level answer at all because inshallah, I hope that we are not going to go to that level. Now, there are a few exam style questions which you can see and attempt, and then inshallah, you'll be able to manage this topic very well. Now, moving to the next topic. Types of programming languages, translators, and IDEs. No, but before we proceed to that whole discussion, first thing that we need to know is a program or a programming language. So what is a program? A program is a list of instructions that are enabling a computer to perform a task. And these instructions are followed in a sequence. You can say a sequence-wise instruction that are there to help in any task. It can be as big as, you can say, a controlling environment, or it can be as small as simply adding two numbers. But they all are programs because they all are there. They all contain a list of instructions that are needed to perform a specific task. Now, when it comes to program development, definitely we need a programmer. And programmers are going to make use of different programming languages. Just like us, for example, we communicate using different languages. Similarly, we are going to talk about computer also, they communicate using different languages. Mainly in our syllabus, we talk about high level and low level. And what are they? I'm saying that for you people, otherwise, and then they're bifurcating low level into assembly and the machine code. So for that, you need to be very clear about the term high level. What is high level? What is its advantages and disadvantages? Why is it popular? So first thing, high level languages are used by the majority of the programmers as they make it much easier and quicker to develop and maintain the programs. Now be clear, maintenance of the program and development of the program using high level is very easy, very less time is consumed in order to write a program in high level. Examples for you, Python, a very popular language, C, C++, Java, Visual Basic, and many other earlier ones, they all are examples of high level. But when you talk about the low level languages are used by programmers who need to develop special routines that make use of that make best use of the memory. So whenever your concern is using the best use of the memory, then you go for low level. Because here the computer's instruction set is going to be handled much better in low level as compared to the high level. And here we talk about most programs are written in assembly language, which is translated into machine code. But just be clear, whether you are writing a program in high level or low level, or you are writing, they all need to be translated into the computer language to be understood. If that is not there, then the computer will not be able to comprehend, the computer will not be able to work on it because it only understands the machine code or the machine language, the zeros and ones, the binary language. Okay, any questions? Now here we can
No, it's good.
the high-level languages, advantages and disadvantages. Again, a very well organized form in it, it is present advantages independent of the type of computer being used. Or you can say it is not machine dependent. Means it is not dependent on the car type of computer. Like for example, just giving an example to make you recall and understand. If I say it's Intel or AMD, Intel architecture is different and AMD's architecture is different. So when I'm designing a program in high level, the same program will run on both the architectures because it is independent of the type of computer being used. This is the first one. Easier to read, write, and understand and debug also. Quicker to write programs. This is also an advantage. Easy to read, write, and debug. Understand also. Programs are easier and quicker to debug. Easy to maintain programs in use. And maintenance means making changes in future maybe. Disadvantages, programs can be larger because they are going to consume more memory. They are going to take longer to execute, although we don't realize, but in reality, the ones who are programming in both high level and low level, they can very clearly tell you that high level language programs are going to run a little slower as compared to low level language programs. Programs may not be able to make use of special hardware. And this simply means that you cannot make use of the registers, that the ones that we talk about. But if we talk about the low level languages, can make use of special hardware, that is the registers, they can work on registers. They can make use of special machine dependent instructions. So machine dependent instructions are available in your low level instruction set, but not in your high level. Code doesn't take up much space in the primary memory, can perform the task very quickly. So whatever were the disadvantages of high level are converted into the advantages for low level. Now, coming to the people, for us, it is going to take longer to write a program. And it will be too difficult to debug a low-level language program, let me tell you. And programs are more difficult to understand for the humans. Just be clear, when we say difficult to understand, it is with respect to the humans, not to the computer. Computers are able to work on them a little better, a little faster. And here, the assembly language they are talking about, low-level languages are bifurcated into assembly and machine code. And here you need to know the term mnemonics. These are special, can say the special words. I mean, for you people, I'm saying for special words or special instructions that are needed, and these are needed to make the computers function on different things. Again, remember, assembly language needs to be translated. Without translation, assembly language program will never be understood. Talk about machine code, it is written in binary, can be executed straight away because it is computer's language. It does not need any sort of translation. The way we said, something that we understand immediately. So this is computer's own language. That's why it is understanding better. It is understanding faster. Got it? Now,
Yeah.
going to the next thing, mnemonics. Just be clear about the term mnemonics. Mnemonics is okay. Just giving an example to make you understand, like just an example, not to like for example, if I say STO, that STO is basically a mnemonic. If I say ADD, that is also a mnemonic. If I say INC, that is also a mnemonic. If I say SUB, that is also a mnemonic. So these are certain mnemonics which are having a certain meaning in your assembly language. So these are your mnemonics. Okay? Now the
Yeah.
translators, why translators are needed? This is what we talked about. That translators are needed to make the program understandable to the computer. And here, there's no translator needed for machine language. I think it's very clear. So which are the translators? CLI. This is a shortcut. C for compiler, I for interpreter, A for assembler. And compilers and interpreters, they both are your high-level language program translators. This one and this one, C and I. And when we talk about assemblers, they are the low-level language translators. So they are needed to translate a low-level language program, or you can say assembly language program. Now, what is the difference? Compilers and interpreters, they both are high-level language translators, or they are translating high-level language program. Be clear, it's the use of the term high-level language program that should be a part of your answer to get the full thing. Then talking about the assemblers are low-level language translators. You can say programs written in low-level language are translated into machine code. Now, the difference between the two, compilers are translating the entire program into machine code in one go, and they generate an executable file. So you can just talk about these two things. The moment a translator compiler is used, it is going to take the entire program and will convert the entire program into machine language or machine code, and it will generate the executable file, and that is needed to run. Now we can see one high-level language statement can be translated into several machine code instructions. Several machine code instructions is something that is similar between both the compilers and the interpreters. We can see here. This is the similarity. This is the similarity between them. Once compiled programs are run without the compiler. So once you have compiled the program, its executable file is created and you give it to me. So I do not need the program. I can work on the program because of the executable file. Like you talk about all the applications that we work on, they all are compiled files, or maybe they are assembled files. They are in the executable form. We simply use them. We simply work on them. We are not at all bothered about the source code, the program, because it's not for us. It's not for our understanding. A compiled program is usually distributed for general use. So whatever the general use, like the way I said, no, talk about the machine code, talk about the MS Office programs. They are either compiled or assembled. If errors are detected, an error report is produced. And remember one important thing, until all the errors are removed, the compiler it will never ever make the program run. It will only create exe file once the program is free of all other errors. And it will show you a list of errors. Maybe just giving an example that maybe the line one has an error. So it will show you a long list of all the errors because it has encountered one problem. So that is why we have to be very cautious, like C, C++, Java, they all are compiled languages. They all are translated. They all are using the translators by the name compilers. Now, moving to interpreters, as the name implies, interpret. They are taking one high-level language program instruction, one statement at a time. They take one statement, translate, execute. Second statement taken, translate, and executing. And in this, there is no executable file being created because it is taking each statement, translating, and executing. Okay, fine.
Yeah.
Again, an interpreted program cannot run without the interpreter. So you always need, like, just give an example, Python, for example. If I'm working on a Python program and I want to give it to you, so you need to have the Python program also. If Python isn't there on your PC, you will not be able to see the program or run the program. So that is because Python is an interpreted language. So interpreted programs cannot be done without the interpreter. Interpreter is often used when a program is being developed. Remember, when the program development is happening, then people or the programmers prefer to use an interpreter rather than a compiler. If an error is detected, execution stops and an error message is output. And the moment you have made the correction, so it starts from the same point where the error has occurred. So this is how the whole process is done. And any questions before I proceed to the assemblers?
No, it's good.
Translates a low-level assembly language program into machine code. This is what the main thing about it is. Executable file is produced. One low-level statement is equal to one machine code. That is what is the main thing. And definitely you can see one low-level language statement is converted into one machine code. So definitely it will be working a little faster. Assembly programs are used without the assembler, like the people do not have the assembler at all because they work on the executable file. Assembly program is usually distributed for general use. So a question can come in the paper. They may ask you to talk about the similarities and differences between compilers and interpreters. They may ask you to talk about the similarities between compilers and assemblers. Just asking you. If a question comes in the paper that write one similarity between compilers, interpreters, and assemblers. So what will you write? What can you write?
A difference?
Similarity between all three of them.
Oh. They all translate like into machine code.
Exactly. They all are translators. And then you can see the differences. Then they can ask you the differences between compilers and interpreters. They can even ask you about the similarities between the two. So what will you write? For example, what are the similarities between the two?
They both translate in from high to machine code, like high language to machine.
High-level language program to machine code. Great. And what else? There's another similarity. This one.
They can both be run without
No. Similarity between compilers and interpreters. First one is they both are high-level language program translators. And secondly, one high-level language statement can be translated into several machine-coded statements. That is again a similarity between them. Okay, the
Yeah.
others are the differences, though the ones that we like, these are the differences. This one statement at a time is a difference. Then you can see like these are the differences.
Yeah.
Okay, so just be clear.
Yeah.
I mean, question can come in this in different style. I'm just talking about the things so you can understand. The question can come in any style. You should be able to answer. Okay, fine. Now
Yeah.
this is your you can see this is yours. Just training you to answer the questions. Okay, executable file not
Yeah.
being produced is again a difference. So these are the two similarities only. If I talk about the similarities, so similarities are basically these two only.
Yeah.
These are the two similarities. High-level language program translators. But this one statement at a time is a difference. Executable file not being produced is another difference. Okay, got it?
Yeah.
Fine. Now, again, similarity between compilers and assemblers can come in the paper. So here we can see compilers and assemblers are, you can see similarities are distributed for general use. That is also for general use. Used without the assembler, used without the compiler. And executable file is exe file is produced. That is also creating executable file. But these are the differences. This is a low-level language translator, program translator. This is a high-level language program translator. And by the way, the questions are coming recently, so you need to be very well prepared for this topic. Now, moving to this one, you can see a very quick discussion about the advantages and disadvantages. Interpreter takes a longer to write, test, and debug programs during development. and easier and quicker to debug, test, and edit programs during development. And programs cannot be run without the interpreter, can take longer to execute. And a compiled program can be stored ready for use, can be executed without the compiler, takes up less space in the memory, executed in a shorter time. So now they have mentioned the advantages and disadvantages of compilers and interpreters in a very organized manner to make you understand. Okay. Now moving
Yeah.
to the easier and quicker to debug, test, and edit programs during development, and takes longer to write, test, and debug programs. Cannot be done without the interpreter. Can take longer to execute. And now this one. Now, last topic of this chapter is integrated development environment. And again, first thing that you need to know is what is IDE. It's basically a software that is needed to design the program, to run the program, to do everything. Like you want to write a program, you are going to open an IDE. Once you are done with the writing of the program, you are executing it. That is also IDE. You want to edit the program content because of any reason, that is also IDE. And examples include PyCharm, like maybe if you have heard about PyCharm for Python, Visual Studio for Visual Basic, or maybe BlueJ for Java. These are the IDEs. And they are speeding up the development process. Because when you are given a platform or you're given a place to write the code, then that becomes easier. Now, what are the features? First, let's talk about the features and then we'll talk about them. Code editor, translator, runtime environment, and the debugger, error diagnostics, auto completion, auto correction, auto documenter, and pretty printing. Now, let's talk about these individually one by one. First thing, I said, it allows a program to be written and edited without the need to use a separate text editor, speeding up the program development process. Now, just telling you one thing, like just giving you one example, like for example, if I want to design maybe a web page, I may need Notepad to type the program, and then I may need another program to run, like web browser. That is not IDE. I need two things. Translator, you can see, can be a compiler and on an interpreter, enables the program to be executed under the control of the IDE. Translator, that is also a part of the IDE. You don't have to shift to any other thing. The IDE is providing you. Runtime runs a program under development, allows the programmer to step through the program one line at a time. Now, this is what I need you to know. This is what the debugging tools are: single stepping, breakpoints, and report window. For you people, you need to know their names because if the question comes in the paper that write the debugging tools, so you can mention single stepping means it will be debugging one line at a time. Allows a programmer to set the breakpoints and allows a user to have the report window. And that is going to show the contents of the variables and expressions, which allows the programmer to check for logic errors. Now, these tools are simply needed to find the logic errors. Remember, one more term, along with source code and object code. Source code is what I type, understood by me, not by the computer. Object code is what the computers understand, not by me. It's not meant for me, it's for the computer. Similarly, when you talk about the compilation process or the translation process, a computer may encounter syntax errors which are detected by the translators because that is the violation of the programming rules. You're not writing the rules, you're not writing the syntaxes properly. And logic errors may be just a giving example. You did the you found the percentage and you've encountered that the percentage of a student is coming as maybe in negative, or maybe it is coming much beyond than 100. It means that is a logic error. And logic errors are never detected by any of the translators. So they are detected by some debugging tools. And report window is a very helpful tool. Error diagnostics find possible errors if the program code is being typed. Now, this is one thing. Once you inshallah start making a program, that you will encounter. Once you are designing the program, then sometimes the errors are shown to you. Context sensitive prompts with text completion, variable names, and reserved words. Reserved words are simply the words that are used by different programming languages. So once you are start typing in the IDE, you will come across different reserved words. Alerts the programmer to errors, provides suggestions. See, just so simple. A programmer is even told what is the suggestion so that he can improve himself. Auto documenter explains the function and purpose of keywords. The moment you start typing something, like just give me an example of print, just a very simple example. It tells you what the print function is going to do. And most important, but not the least, is pretty printing, color coding. Like, for example, if I'm writing a program, if the color code is different and I have been programming maybe for long, I can figure out that I have made a mistake there. This pretty printing is a very important tool that is very helpful, ID tool for the like ID tool or feature that is very helpful for the programmers. Now, a few sample questions and answers are here, and then it ends this chapter. Programs in high level can be translated by different types of translation programs. Identify two different types of high level language translation programs. Difference between the two high-level language translation programs. Programs can be written in high level or low level. Explain why would you choose to write a program in low level. So just the features that we have talked about will be giving you the answer for this one. And then you can see the compilers and interpreters is the answer. Translates the whole program at once and produces a file to be executed later. Whereas an interpreter translates each statement, then executes it before moving to the next statement. So these are your example high-level answers for these questions. And then a few exam-style questions are here for you. And then a few past paper questions are here for you. And that ends the entire chapter. So any questions before we finish our lesson for today?
No, it's good.
Okay, Jazakallah khair Kasira for being a part of the learning journey. Hope that you have understood each and everything. Please do subscribe the channel, share with your friends and family so they all are going to benefit from it. Okay, Allah Hafiz from my end. May Allah bless you. May Allah help you.